In the back of our robot, we have a camera to detect our custom-made signal sleeve. First, we're going to push our signal sleeve out of the robot's way. Then we will outtake onto a load junction. It pushes out of the way. It outtakes onto a load junction. Then we're going to go to the cone stack and intake a cone from the cone stack. Next, we have a distance sensor on our linear side to successfully align the robot with the junction, and then we outtake the cone onto the junction. We have a color sensor on the bottom of our robot, so we can strafe and align our robot with the blue tape. We intake and then we commence outtake one more time, cycle a cone onto the high junction, and lastly we will park at the designated parking area.
Sensors. Our robot contains a variety of sensors to improve driving in both autonomous and teleop. We have 3 odometry wheels which are used in autonomous to improve localization in Roadrunner. We also have a color sensor which is used to as the tape detection. We also have a limit switch which is used for intake. Our 3 odometry wheels are retractable to improve accuracy, and the wheels are used to help us with localization during autonomous. We use Roadrunner so we can use different maneuvers such as spline curves so we can have the fastest and most efficient autonomous possible. We also have a color sensor. This color sensor is primarily used in autonomous so we can strafe, so we can align ourselves with the tape and align ourselves with the cone stack. We have a limit switch. This limit switch is used in autonomous and teleop for intake, so our robot knows whenever a cone is inside our guide, so we can initiate intake. We have 3 distance sensors to align our robot in teleop and autonomous. The left and right distance sensors are used to decrease speed whenever it detects the junction. The center distance sensor is used to stop the robot once it's fully aligned with the junction, so we can proceed and outtake. The left distance sensor is used when turning counterclockwise, while the right distance sensor is used while turning clockwise. These 3 distance sensors are crucial to align the robot with a junction. We also have a limit switch on our cam. It detects whenever a cone is fully inside our cam, so we can turn the servo and intake the cone. This is useful to automate driver controls, so we don't need to manually press a button to intake the cone.
For signal visual detection, we created 3 individual videos for each type of image under different backgrounds. We used the medium flow algorithm to label over 300 objects to create the model file.
Junction auto alignment. For junction auto alignment, our robot will turn at high speeds clockwise or counterclockwise to align with the junction. Firstly, the robot will turn at high speeds until the side distance sensor detects the junction, and then it will switch to lower speeds until the center distance sensor detects the junction, where it will then stop and proceed in outtake.
Cone stack alignment. Our robot strafes to locate the color tape using the bottom color sensor. We align the robot to be perpendicular to the wall, and then our robot drives forward to pick up the cone precisely without cone stack movement. Auto intake. We have plenty of enhancements to make intake and teleop easy for the driver. First, all the driver needs to do is to drive the robot until the cone touches the guide. Once it hits the guide, the linear slide will collapse until the linear slide cam's sensor hits the cone. Then the cam will lock, and then the linear slide will rise up in one fluid motion.
Our outtake process is completely seamless, only requiring one driver button press. When the button is pressed, our robot will start spinning at high speeds until the side distance sensor detects the junction. Then it will change to low speeds and wait until the middle distance sensor detects the junction. Then the robot will start moving forward and wait until the cone hits the junction, and then the robot will stop and drop the cone. Once the cone is dropped, the robot will move backwards and collapse the linear slide in one fluid motion before drivers regaining control to the robot.
Thank you for watching. I hope you have a good rest of the day.